Has it started sharing? Can you see my screen?
Yes, your screen is blank, but we can see it.
Okay. Can you see anything? But it's just saying my screen is black. So you're sharing.
I also just see a black screen.
Oh.
But we can see your cursor.
So maybe just open your presentation again.
Okay. Oh, I start afresh. Okay. Okay, bear with me for a minute. Still open.
Still not. Just try to stop it for now and try again. So to stop, just wait over with your mouse on the top of the screen. You get a drop menu there. Then go to stop sharing and then try again.
Oh, okay, okay. I've gone to stop sharing. Then I'll try and share again.
Just make sure you first open your screen and then share that particular slide.
Okay. Do you see the slide now?
Yes, yeah, there we go. We see it now.
Okay. Okay, no, thank you and good afternoon, everyone. My name is Polokano Sekonopo from the University of Botswana. I'm a lecturer in the Department of Industrial Design, and as well, I am a part-time doctoral candidate. So the study that the paper that I'm presenting is part of my doctoral study. It is titled Product Innovation as a Catalyst for Job Creation. And this is the presentation outline. I'll take you through the introduction and some literature review, as well as the research methods and the findings. This study is looking at the successes attained by developed nations as far as product design is concerned. This success stems from the first industrial revolution, which has led to other countries to pursue industrialization as a means of national development. African countries have fared badly as far as industrialization is concerned, despite having had the resources to start industrializations in their own countries. By this, I mean that, well, most countries have had mineral resources, which they could have used to industrialize their countries. This has been referred to as the mineral curse, and Botswana is currently grappling with efforts at industrializations upon realization that diamonds are not forever. Industrialization is all about manufacturing, and because manufacturing has been identified as an entity for possible job creation and can absorb the masses. Globalization has also acted as a motivating factor, since products produced in one country can be sold in another country. Globalization also acts as a double-sided sword, since those countries which are unable to produce for themselves don't have much time to learn, as they tend to rely on products produced in some countries. The literature that I reviewed has shown that around the whole world, countries are looking for ways of improving the livelihood of their citizens, and job creation is one of those ways. This is based on the opinion by Holmes and others, who opine that prioritization of employment creation is informed by a prevalent assumption that employment has a positive impact on poverty reduction and stabilization. This has led governments creating, in a bid to create entities which will create employment for their citizens, turning up to devising means of empowering their SMEs with the hope that such assistance can help in creation of jobs. Such assistance is in the form of grants, subsidies, mentoring, factory shells, and so many other interventions. These interventions are mostly targeting the small, micro, and medium enterprises, our SMEs. This is because they contribute a lot to job creation and income generation. The downside to this is that though SMEs contribute a considerable amount of jobs, they are characterized by a high failure rate. Also, there are many advantages of focusing on SMEs because SMEs are the highest employers. SMEs tend to use materials which big companies tend to shun. For example, SMEs are currently using wooden pallets. SMEs are currently using car tires and so many other discarded materials which will otherwise not be used for anything. Holmes and others outline the following as employment creation programs that can be adopted by countries. Direct, short, or long-term job creation by state or non-state actors. Policies for promotion of self-employment. Policies to stimulate employment growth. Job subsidies to sectors with high employment elasticity. However, Botswana government has tried all of the above, but still unemployment is spiraling out of control. And this points to a missing link somewhere. Some have said that the reason why Botswana's SMEs are not producing enough employment is because there's a small market, therefore their products they can't produce many products which can be sold to the market. But Ngek and Art Smith 2013 from South Africa also paint a gloomy picture about South Africa, where they observe that in South Africa, 5.9 million small businesses create about 7.8 million jobs, which indicates that on average, each small business creates less than 2 jobs. They further state that 94% of South African small businesses have less than 5 employees, with up to 67% of them having no employees at all. So it shows that SMEs locally here in Botswana and or maybe in South Africa are not creating as much employment as literature tells us that in the developed world, SMEs are producing that much. In a bid to make SMEs, product manufacturing SMEs to make products, there is what is called product innovation, which is also known as new product development. Yesterday, Prof. Trimble talked about design engineering. Design engineering and new product development are the same thing. And this design engineering or new product development is the process of coming up with a new product. And the product innovation prowess has been identified as the missing link in Botswana manufacturing SMEs by the current study. There are different product innovation methods used by different companies to come up with products. A sample of those are IDEO company, which uses IDEO method, Toyota Motor Corporation, which uses set-based concurrent innovation, and Botswana SMEs are expected to use the Booz Allen and Hamilton method because this method is used in Botswana high schools. There is the IDEO method. It starts here with the design challenge or the theme. And when you get the theme, there has to be some research which is carried out to fully understand the product, the problem, and how it is solved. Thus, by so doing, the team diverges on the issue and converges to come up on a problem to focus in, and then they ideate, then use a prototype, test the prototype, refine it, and deliver the product. Now here is the set-based concurrent engineering method, which is used by Toyota. When they're coming up with a product, what they do is they come up with a number of concepts and they take those concepts further. They don't just take one concept. With the traditional method is that after coming up with about 4 concepts, you choose one and go further with one concept. But in Toyota, they don't choose one. They come up with several concepts and they take them through the design process and testing stage till they end up with choosing maybe two to fully manufacture and fully test. And as far as set-based concurrent engineering is concerned, whenever they come up with a set of design possibilities, they at the same time look at the set of manufacturable possibilities, whether this particular design, is it manufacturable there and there, okay? And now here is the Booz Allen and Hamilton method. This method is the one that has been adopted by Botswana high school system. Students are taught this method from Form 1 up to Form 5. Form 1 should be Standard 8 in South Africa. And this is how this method has been interpreted for the schools, and this is the method which is followed. So in the study, I was expecting to see SMMEs following this particular method because it is the one which is taught in Botswana schools. The methodology adopted for this study was qualitative method, and this qualitative method involved the use of interviews and observations and workshops, and a small percentage of quantitative method of a survey was employed to identify entities to be taken up for the qualitative study. In selecting the population, I used the RAWSoft online population determination software, which gave me a number of about 96 SMMEs for a sample of a confidence level of 10%. And I used the survey questionnaire and the interview and the observation. The questionnaire had 3 sections. The interview just had questions similar to the questions of the questionnaire because the interview was just to clarify these questions, and the observations looked at these. The findings, out of the 96 participants who were targeted, only there was 54 returned questionnaires, and out of those 54, 53 entities had only 1 to 5 employees. That meant, by Botswana terms, when a company has got less than 6 employees, it is referred to as a micro. When a company has got 6 to 24 companies, it is referred to as a small. Then 25 to 99 is a medium company, and 100 and above is a large corporation. This differs from country to country. So you can see the sad situation about here in Botswana that the bulk of companies fall under the micro. They've got less than 6 employees. Now, when you look at the years of operation, companies which have less than 5 years are 32. And when you look at on the graph this side, 32. And those which are 5 to 10 years, they are just 10. 11 to 15 years, 5. 16 and above. This is a really unpalatable situation in that 1 to 4 years has been determined or is regarded as a very volatile time period for a startup company because the company is not yet grounded in the intricacies of business. Here is the findings of Section B and Section C.
I hate to interrupt you, but I'm just alerting you, you have 1 minute left.
Okay, this is the product innovation model. You can see that here, B1, we just wanted to check the product innovation model Botswana SMEs are using. And the score, there's just so many zeros. These are different companies. So many zeros, which means they don't have a product innovation model. Not having a product innovation model is just like a team playing a game of football and not having a system, which is very dangerous. So from the interview findings just confirmed what the questionnaire found, and most participants did not have formal knowledge about product innovation. They had not got formal innovation like certification. And at observation, I had wanted to use the so-called rapid plant assessment form, which is used by the Japanese companies when they go around the world looking for companies to buy or to take over. So, but when I tried to use them in Botswana, I found that they could not be used because Botswana's product innovation scenario is completely far away from that, though we are trying to move towards that. And in conclusion, it has been found that Botswana SMEs are not providing enough jobs. Botswana's SMEs have got a high product innovation apathy, and there's a need for a product innovation model to be developed for Botswana. And also the government of Botswana should devise programs to reach the general public concerning entrepreneurship and product innovation, because by so doing, consumers would want better products, thus making the SMEs to come up with better products. Thank you.
Thank you so much. What a fascinating project you're working on. I have quite a few questions, and I'm also just alerting everyone that if you have questions for the various speakers, please take note of them. I just want to see who our next speaker should be. So, and I neglected to do something which is very rude of me. Polokano and Refilwe, people that don't know me. I'm Amira Osman. I work here at the University of Technology. Yes, sorry for not introducing myself.
Okay, so, no problem.
Yes, so thank you, Polokano, for a wonderful presentation. And I just want Letitia, Trevor, we need to give Letitia the option to share the screen. And while she's doing so, please either raise your hand or type in the chat if you have any questions. Polokano, could you tell us a little bit more about this school program? I'm just fascinated by that. So your research is identifying problems with SMMEs, and there isn't enough product innovation, and you've identified that as the missing link with regards to development. I appreciate your comment about diamonds are not forever, and the fact that we need to develop new products. Is there an awareness about that? Is that why this program is taught in schools? Because I thought that's quite advanced. Could you perhaps comment on that before we move on to Letitia?
Yeah, actually, it is taught in schools. The government decided to teach it in schools with the hope that the students, when they graduate from this program, it is called design and technology.
Okay, very interesting. But that I mean, that in itself is a great advancement in terms of awareness of what the problems. Do you agree with me?
Yes, I do.
Yeah, that's incredible. So thank you so much. Maybe some other people will also have comments or questions for you, but I'm handing over now to Letitia. Letitia, you have 12 minutes.
Okay, thank you.
Right. Thank you very much, Amira. I appreciate this opportunity. And firstly, I would like to thank the 9th ICAT organizers for this opportunity to present.
Letitia, today. Your voice, so sorry to interrupt you. Your voice is very far away. Sorry,
okay,
yes, just try and move closer to your mic. And I forgot to say that I'm co-authoring this with Letitia. So if I feel I need to come in at any point, I will. But Letitia, the floor is yours.
Is the sound better?
Yes, that's a little bit better. You can try and speak a bit louder.
Okay, no problem. Okay, so I'm a recent Master's in Architecture student, a graduate from the Tshwane University of Technology. My interest lies in architectural heritage, urban design, and the social responsibility of architecture. So the paper that I will be presenting here today is Community Engagement, Knowledge and Technology Exchange, Academic Reflections on a Project at Bertram's Johannesburg. So to provide you with an overview, the research paper considers how community engagement projects affect residents of buildings and places. This project was part of a National Research Foundation funded community engagement project as well as the University of Johannesburg and the Tshwane University of Technology. The aim of the project is to share knowledge and provide opportunities for residents to learn new skills during the process of renovation. So there were 3 areas of further research that was considered during this research paper. Firstly, it was to understand the daily realities of residents. Secondly, to understand and acknowledge that communities and cities are part of a complex network, and therefore a holistic perspective could add value. And thirdly, that by recognizing these networks, the provision of affordable housing in the inner city contributes to making cities more sustainable, viable, and inclusive. So within this context, the word community refers to, the community occupied building in the city of Johannesburg and the various interactions.
Letitia, we're not hearing you anymore. Your voice is gone. Letitia, we can't hear you at all. Can you hear us? You can type something in the chat. Trevor, do you have any idea what we can do?
I'm just trying to text her to see if she will respond.
Area is also zoned as both commercial and residential, and this makes it possible for future mixed-use buildings or possibilities. There's both historic and sociological significance in this area. The area does have pieces of the past still present, however, there's an optimism within the space. By building on present-day characteristics using participatory action research, that the project enhances the genus loci of the place. So this is the space here, the Bertram's area, and this is the priority block that was studied. So why is participation so important within this context specifically, within inner city projects? So on the 25th of June 2019, the city of Johannesburg posted a notification of a demolition in Bertram's. And this specific decision was taken without informing any of the residents. This led to a We Won't Move demonstration. And if you consider the fact that there are over 119 residents with 13 children under the age of 18, with some residents indicating that they have lived in the building for more than 20 years, this displacement would have been devastating. Moving on to the action that was taken. The action plan was developed by TUT Architecture and Corinne B. UJ Community Engagement Team. And this collaboration allowed for engineers, contractors, architects to all come together and provide a list of what needs immediate attention within the building. So firstly, the structural damage to the roof to be identified. And secondly, design challenges that were needed for safety were identified. So during this process of renovation, it was very noteworthy to see how solutions were found within the moment. And these types of solutions only take place when residents remain involved in a project and the process. So the response then was to repair the bricks, balcony, and also the steel staircase. and this allowed for general safety repairs. After that, a new screed layer was installed on the roof with a waterproof barrier. So this now also not only improved the structural safety, but also improved the living conditions. So these are just some images of the balconies that were restored before and after, and then the steel staircase. And this is the type of solution that happened in the moment. So while the screed layer was being laid, the community members also started repairing the steel staircase. Then, so what does this tell us? The systemic change that needs to happen within architecture education. So this is where the academic reflections help us. So understanding that architecture is not static is the first thing, and that radical shifts are required in the form of a response to dynamic societies in authentic ways. So we often think of radical shifts as being these grand ideas. However, it's oftentimes small responses that make the greatest change. So asking a fundamental question which community engagement projects allow researchers to ask, how can architecture make a meaningful impact? So by understanding and shifting the perspective towards the needs of the user and society, this idea of radical change does not seem bearing, but merely necessary. So what is required? Balance is required to consider both human relationships that support community with technical knowledge and advancing technology at the same time. However, this needs to be in balance in order to create these supports so that multifunctional cities can develop. So the implications of higher level policies and communities. So firstly, the architecture education and practice need to become responsive, and then also furthermore, local policies need to become more responsive. By engaging with research institutions and being updated by changes in communities, policies could become more responsive. So cities need to be adapted for diversity. Participation not only becomes possible, but necessary. And considering the past displacement that occurred in Bertram's, it became very clear that further disruption of place and livelihoods cannot be a solution. So to provide an example, policies that are interrelated yet accommodating. So where heritage councils and local authorities come together, where there's possibly another reuse of buildings, highlight how this can become mutually beneficial, and where this holistic understanding of spaces and places becomes important. So this is important so that policies are adaptable for local situations and also that are specific to the place. So the impact of the interventions, observing change. So during the process of renovation, with the building's waterproofing that was being we asked this question, would this encourage you to start cleaning and fixing the spaces? So we posed this question to the residents, and many residents responded with the fact that they would start fixing and painting the rooms themselves. And this is important to consider. So that small intervention made by the team ultimately helps the residents to start taking that ownership, and that sense of ownership from there on grows. So 3 main changes were observed and identified. Firstly, the physical change, which is tangible. Secondly, change in the response of residents, and this was important to see how residents encourage one another, and also through a sense of ownership. And this is also intangible, and it's a bit more difficult to really describe, but it could be felt during the process of the renovations, and it could be experienced during this process. So this change indicates how architectural academia and practice can develop and remain relevant, but needs to be open to change and accept social responsibility. So all of these ideas need to come together, and that is the only way in which architecture will ultimately remain relevant. So Amir Hamdi's Small Change, Colin Ward references John Turner's first law of housing, and this is specifically relevant here as well. So I'm just going to read the quote. When dwellers control the major decision and are free to make their own contribution to the design, construction, or management of their housing, both the process and the environment produced stimulate individual and social well-being. So, in conclusion, through the various workshops that took place, the meetings and the skills training, these were all based on the needs of the host community. So the project ultimately successfully brought together stakeholders and participants. Realizing the academic benefits, the research also ensured inclusivity in design making and implementation. Secondly, this is in some respects an alternative approach towards housing provision, retaining the existing communities and minimizing the displacement. And this is by considering the top-down and bottom approaches. So, and this is not only of policies, but also of the of architecture education and profession. So these site-level interventions can motivate transformation of higher-level policies. And just a note also, then it was seen throughout this project that the complex context that Bertram's is in, and with the close proximity to the CBD, means that it has the potential to transform into a thriving and viable community with multiple socioeconomic possibilities. And then the third investigation of this research outcome was that small-scale tangible interventions led to greater intangible outcomes. And this was only realized when participation of communities and human relationships are at the forefront of design process. So ultimately, it is important for architecture to be able to adapt and to constantly move with and throughout these spheres of considering social responsibility and participatory process. So I'll leave you with this final note. Architectural interventions allowed for a conversation of the relevance of the profession in contexts like these. Participatory process and social responsibility guided the development of the study intentions and methods. The knowledge and skills transfer become necessary tools for the engagement. Become necessary tools for the evolution of architecture, and these practices of engagement create an opportunity for architecture to learn from and adapt to the needs of people and communities. So I would like to ask my co-author, Professor Amira Osman, if she would like to add any of her own thoughts and reflections.
Thank you so much, Letitia. Thank you so much. I was about to interrupt you, but I gave you an extra minute, so that is very fine. I want to consult here with, before I make comment on this, I want to consult with Refilwe, and I see that Dr. Mahachi has joined us as well. Is it okay if I switch the program a bit, Refilwe and Dr. Mahachi? It's just that we have another paper that's strongly linked to this one. So I thought it might make sense if we present that paper immediately after this one, and then we come to your presentation after that. But I'll only do that if it is acceptable to you for me to change the program. Dr. Mahachi, could we hear your comment on that, please?
Amira?
Yes.
Yes, I don't know why Dr. Mahachi is unable to mute his mic, but if he's fine with it, I don't have a problem.
Okay. Refilwe, could you perhaps comment? Is it okay if I change the program a bit?
Yes, I'm fine with it if Dr. Mahachi is fine with it.
Oh, you are Refilwe.
Yes.
Is it Refilwe speaking? So sorry, I thought it was Trevor, my technical support guy. Sorry. Thank you so much, Refilwe. We really appreciate that. So Trevor, could you please help Suzette upload, allow her to share her screen? So Letitia, you may stop your screen. And I see Trevor has also asked that we please turn on our videos when presenting. Letitia, thank you so much. Yes, indeed, we started this project, myself and Afua, quite a few years ago, even before I joined the Tshwane University of Technology. So we've been working and collaborating with this community for a long time. And in the last few years, several partners and collaborators have come on board, and I'm really glad that you've mentioned our collaboration with UJ and with, because that really started again before I joined TUT. And while we've collaborated on this and I've worked on it for a number of years, I've found that every person that comes into it brings a new perspective. And Suzette, the other day I presented some of your work at the Open Building workshop, and I actually wanted to acknowledge you, and then I found that you had to leave early. But each person that works on this project kind of interprets it or brings a different perspective to it, and I'm very appreciative of that. So Letitia, I've really appreciated how you've presented this and framed it within the context of looking at these small interventions, but the kind of impact they have at a larger scale, which is very much a core idea of our project, which started, as I said, a few years ago. This relationship that you've emphasized with regards to human relations and technical know-how, but the most important thing for us when we started this project is these interventions could ultimately help conceptualize a way for transforming these kind of neighborhoods and these kind of contexts into viable neighborhoods. And it's almost as an alternative to current housing programs. So acknowledging the presence of people in these occupied buildings, and like Letitia says, that some people have been there for 20 years or more than 20 years. They, I believe, have a right to remain there, and they have a right for the environment to be improved. And if we can harness the potential of these small interventions and have many, many of them, the impact can be incredible. And I would like here to hand over to Suzette to continue with this conversation. Suzette, over to you.
Have I been unmuted? Can you hear me?
We can hear you now, yes.
Awesome. And can you see my screen?
Yes, we can.
Okay, then let me get started. So thank you for the introduction, Amira. Just briefly, I'm Suzette. I'm not an academic. I am an architect with an interest in academia. I work as a project manager for One-to-One Agency of Engagement, which is a non-profit that looks to provide socio-technical support to under-resourced communities. So I'm fortunate in that some of my time can be spent on other things because Letitia has already introduced the project, but essentially this paper that I am presenting today is a paper between myself, Prof. Osman, and another of our colleagues, Afia Wilcox. And the main themes of the paper really look at the challenging relationships that came about during the physical implementation of the project. And then secondly, also the sort of advantages that come about when academia becomes involved in communities where resources are quite scarce. So some main takeaways from the paper were really that community engagement projects have tremendous value, and to different stakeholders, they mean different things. Then also really talking about the challenges experienced during the implementation of the community engagement project. So around issues of volunteerism, stakeholder networks, and the power dynamics that come about during these experiences. And then also sharing just a couple of lessons for community engagement projects in future. So firstly, and I don't have to do too much context here, Bertram's is located east of Johannesburg CBD. It's located just east of Ellis Park. Bertram's was developed in the 1930s as a sort of middle income housing for the working communities that were associated with the mining industry in Johannesburg. And over the years, it's undergone a series of transformations. And it was actually considered one of the first suburban areas that was an integrated community in sort of the late 80s. This was at the time that Hillbrow was also becoming quite a cosmopolitan before the abolishment of the Group Areas Act and those sorts of things. So these kinds of, it has always, because of it being sort of on the periphery of the city, it has remained out of the spotlight. So things happen there without anybody knowing. So then just an introduction to the project, really. The Housing and Urban Environment Studio started in 2010 at the University of Pretoria by Prof. Osman, and it's sort of been through a series of iterations and has been resident at a number of universities. In 2016, it was moved to the University of Johannesburg, where it became an elective for architecture students. And the elective was actually, they were hoping to look at urban environments, and that's why they reached out to the Inner City Resource Centre, which is a non-profit that's been operating in Johannesburg for 20 years, and it looks to really represent the needs of under-resourced urban communities in their plight for safe, dignified, and affordable housing. So from 2017 to 2019, the studio was run every single year at UJ with up to 50 students completing it. And every year the focus sort of became broader and broader, really going from the issue of housing on a building scale to a city scale or a neighborhood scale. So during these modules, students engaged with residents to develop ideas and really start analyzing what the big challenges were. And we looked at one building in particular. So in 2019, and this is when I joined the project, my role was to implement these upgrades based on the recommendations that the students had made. So these major upgrades included the reparation of the slab, making the slab waterproof, fixing that steel staircase, repairing those brick balustrades, and then fixing the illegal electrical connections, which Letitia has already shared with you. And then now we're in 2020 and the project is ongoing. It's ongoing until 2021. And this year, we've actually formalized the agreement between D1-2 and the organization that I represent. And we are actually taking these upgrades further. So in 2020, the project has started looking at the neighborhood and has specifically hoped to address COVID-19 exacerbated issues. So we're looking at special interventions at the neighborhood scale with a series of workshops with representatives from the community. So the advantage of community engagement projects at universities really is that there's an exposure to a real world context, which is invaluable for students. It also then fosters a sense of sensitivity towards other environments. I think often students are occupying a position of privilege and they move through cities every day without knowing what happens in those cities. And by doing this, they actually start opening their eyes to what is happening in the rest of the world. But additionally, these community engagement projects allow us to channel resources that would typically, because they are learning resources, these resources would actually never leave the campus. We're bringing those into the city where they can contribute more. And then the last benefit is that it actually allows academics, so I'm talking about lecturers and researchers here, to remain present in their profession, which is something that often they lose track of. So I'm just going to quickly get through these. Oh, I'm going backwards, sorry. So essentially, the process was an action research process, and we believe in service learning. So then the workshops, obviously, as Letitia explained, we worked with residents. They worked with residents to determine what the needs and challenges are, and then we made a number of repairs to the building. So it was balustrade, the steel staircase, the roof, the underside of the roof, and the electrical cables that were exposed on the roof. So we relied very heavily on resident engagement, and this is problematic as an outsider when you're entering these spaces. So essentially, it was important to understand the relationships between people and things. So firstly, if you have the priority block is constantly, challenging the city of Joburg for safe and inclusive housing, and they do this through their mobilization by ICRC. ICRC was then contacted by the Housing and Urban Environment Studio, which hoped to get learning in exchange for resources. And these resources came through the National Research Foundation, and then one-to-one starts becoming the implementing agent. But essentially, this relationship between ICRC and the priority block was critical. So the role of this relationship was invaluable, and it allowed us to really get buy-in from the residents. It was important to use ICRC as a channel to introduce new team members, to establish those relationships of trust. And then lastly, it was also important to understand the social dynamics within the building and to often prioritize tasks that promoted those relationships and encouraged user participation in as many events as possible to ensure that buy-in remained and that good relationships were maintained for future tasks that might not involve so many residents. So we learned that engaging through these established relationships and understanding that the social dynamics improved the likelihood of resident support. And this sounds quite obvious, but you only learn this lesson by making this mistake, really. So self-help is the mandate of ICRC and a number of grassroots organizations, and a number of the residents of the priority block are unemployed. It therefore seemed quite obvious to us that we should use a skills training initiative to put the residents to work in repairing their own building. And we believed that to maximize the resources, we would offer an honorarium to the volunteers to thank them for their time and their participation. We thought it only fair. However, this brought about tremendous challenges and learnings and some conflict along the way. As soon as you start issuing payment for something, then you're setting up a different set of priorities and values. So, and then additionally, the idea of skills training. Skills training is a very politicized idea, and we often see it as a tool for economic redress. However, the idea that I, as an architect or as an academic, have anything to teach somebody who probably has been doing the work that I'm trying to make them do for much longer than I have been on the planet is quite an arrogant thing to do. So from the experience of being on the ground, it actually brought us to question that whether or not people are not employed because they don't necessarily possess the skills, but because they don't have access to the opportunities to put their skills to use. So what quickly happened is that despite us offering skills training by a formal contractor, the formal contractor didn't arrive quite as early as we needed him to, and one of the residents of a neighboring building put himself forward as a skilled bricklayer and ended up providing training by building as opposed to a managerial role. And so the brickwork commenced much faster than we expected. And in my ongoing experience on the site, this has kept happening, that there are residents who can do things if you just sort of ask the right people. But then another issue that this brought about, and this is one that I'd like to explore in future work, is that my role as an implementing agent, the person with access to money and who makes sort of financial decisions and the face of the funding, as a young white female on a construction site, that brought about a number of other issues. And these are things that I definitely would like to explore in future. But then outside of that, sort of the third takeaway from this is bringing me back to my points around community engagement projects and the value that they pose, is that South African spatial environments are incredibly complex, and we are sort of plagued with a heritage of spatial inequality, and that by allowing students to engage in real world environments where there is a need for resources, students are exposed to these realities and they start understanding it. And as opposed to a traditional act of charity where somebody would sort of, reach out at a shelter, for example, by participating in this way, they see the value of their profession in the realities and the spatial inequality of the country. So the nature of the academy is, yes? Oh, okay.
I just need you to wrap up.
Okay, I'm on it. So this relationship and this exchange is incredibly valuable because we can channel these resources to where the resources are most wanted. So these are just like some key takeaways that are in the paper, and you can go through them. But I think the major experience is that learning from the real world is incredibly important. But we must understand that these are real people and real environments, and we must be incredibly careful. So then just quickly, updates on the project. The project has since seen us get new researchers as part of the team, which has been quite great. And then our project focused on water and sanitation in the area. So we've been working in some neighboring buildings. We actually built some toilets for one of the buildings that had no access to toilets previously. And then there were these sort of natural developments that occurred in the building where residents had started, after we had repaired the roof and had started doing other things, they started addressing their own needs, particularly in terms of water and access to water. And then lastly, the current project we're busy with is looking at the neighborhood because we established a need for a community space where community issues could be addressed. And this is actually us having designed this park with the residents and then presenting the park as a feedback. So the task team is sharing what they had designed by us physically mapping out the design in the space, and the rest of the community then seeing what's coming. And we've actually started implementing that now. So I'm just going to essentially, thank you for your time. And if you want to follow the project, it's at the Housing and Urban Environments website. Thank you.
Wonderful. Thank you so much, Suzette. Really appreciate it. Yes, I forgot to mention that Dr. Mahachi is from the University of Johannesburg and also on the board, if I understand correctly, is now chairing the board for Karimbi. So that's an important partner for us. And yes, before I say anything, I have a lot to say, but before I say anything, I just want to check if our speakers from Brazil are here. I just want to ask Gisela Mascarenhas or Roberto dos Santos. Is either one of you perhaps here, or a representative from you? I'm guessing not. That means we only have one more paper to go. So Trevor, could you please help Refilwe share his screen? Thank you so much, Trevor. So thank you, Suzette. You say you're not an academic, but what you are documenting and what you are doing now is incredibly vital for academia. So yes, I just really want to compliment you on that. And I really enjoyed the fact that what you've done to this project. First of all, you've moved it along in very interesting ways and very quickly, and you're very efficient at that. And I have great appreciation for that. But also when I was doing the kind of work you're doing now, working directly, because now I'm mostly facilitating, but when I was doing it, you mentioned, a young white woman in that particular context. And I remember when I used to work in Mamelodi for many years and built up partnerships in Mamelodi. At the time also, relatively young Sudanese woman. I remember I told the story yesterday of how a lot of times I would have a scarf on my head, which traditionally we do. And when the xenophobia hit, I can't remember which year, whenever I drove into Mamelodi or walked or somewhere or went to site, I would immediately take off my scarf, and I would be very apprehensive because I looked very Somali, and Somalis were targeted at the time. So now when you were telling this story about being a white woman working in that context, it's almost like we cannot, we can't be other than who we are. And when we go into particular contexts, certain things are created. Also, the fact that you are seen to hold the money, to have access to resources, that also adds incredible complexity. And the fact that you're grappling with that, engaging with it and documenting it and trying to make sense of it and reading the literature about it is very valuable. So yes, I'll make an academic out of you.
Thank you.
Yeah. But yes, and the fact that we're constantly grappling with you know, the academy, learning and learning sites, and delivering a service. So we are delivering a service, but we're doing it because we're also teaching students, and we're also, for ourselves as researchers, gathering data that benefits our research. And that creates a whole lot of power dynamics and expectations that need to be managed, and very complex scenarios. But being on site, nothing can simulate that. You know, that's an incredibly valuable thing you're doing now. And I just also want to acknowledge the you know, the different perspective that you've brought to this project. So I would like to hand over to Mr. Refilwe. Mr. Refilwe, our technical advisor has said that we need to switch on cameras when we're speaking. So please do that. And if Dr. Maharti is here, it would be great if we could also see him. And I hand over to you. Welcome.
Thank you, Amira. A very good afternoon to everyone. As per introduction, my name is Refilwe Lidiga. I'm a PhD student at the University of Johannesburg. I'm focused on the applications of 3D concrete printing in the construction industry. The paper I'm presenting today is on the prospects of 3D printing of houses in South Africa. This is a paper I co-authored with Dr. Maharti, who's also here today. So this will be my presentation outline. And our problem statement was as follows in our paper, that South Africa has a backlog in excess of 3.5 million houses that require an estimated 800 billion by the end of 2020. So an urgent and innovative housing solution delivery, excuse me, I just have a problem with my WebEx. Yes, an urgent and innovative housing delivery solution is required. A solution to this backlog could be the use of what we call a technology called 3D concrete printing. The critical consideration for 3D concrete printing is the construction costs and whether it could fall within the provision of government housing subsidy quantum. There are numerous walling technologies in South Africa, but not all of them have been successful. And although 3D concrete printing has been tested internationally, it has not been tested adequately in the South African context. So the potential benefits of the type of skills and labor required using 3D concrete printing has not been adequately researched as well or documented in the South African market and context. So the aim of this study is therefore to explore the following: to look at literature review on the extent of the adoption of 3D printing and the types of technologies used worldwide. We'll also look at the viability of this technology in the country. We'll explore the use of waste material, and we'll conclude with looking at comparing 3D concrete printing technologies from a cost point of view with a conventional method. So although 3D concrete printing is relatively young technology, there's substantial research that has been done throughout the world. And there are two fundamental factors to take into account to make it successful. One important factor is the machine, the 3D concrete printing machine, and the other important factor is the material design. There are also other approaches, design approaches to 3D concrete printing. So the commonly used machine designs are what we call a gantry-based system and a robotic arm system that I'll show in the following slides. So on the left of the slide, we've got a conventional gantry type system. One of the advantages of this system is that it's a generally stable structure for the use of construction. And as compared to a robotic system, it's relatively inexpensive and is suitable for building large-scale buildings on construction sites. and generally has high material flexibility. Now, the disadvantage, however, are that it's a monolithic structure, as you can see. It's difficult to move from one place to another if you are printing multiple houses. And it takes time to set up and calibrate. It takes around 6 hours to set up and calibrate. Then the next printer I spoke about is the robotic arm system. Its advantage is that, as compared to the gantry system, is that it's a very portable system. It's very mobile to move around. However, the disadvantage is that when you're building a huge structure, you'd have to build in pieces and similar to Logo pieces. It's relatively expensive. It's got limited material flexibility with a lot of manufacturers, and it's more complex to operate as compared to the gantry system. What's interesting, though, is that there's been a lot of 3D concrete printing projects in recent years. As you can see in this graph, in 1997, there was only one documented 3D concrete printed project. And as you go to 2000 and let's say 13, we started seeing 2 projects a year. And in 2015, there were around 6. In 2016, there were around 8. But when we came to around 2019, there were more than 10 3D concrete printing projects across the world. So the industry is slowly growing. With regards to the recipe or the concrete material mix design, what I have on the screen is sort of like the fundamental mix design that's used in industry. However, there are various mix designs out there, but they always bear reference to this fundamental mix. We also explored recycled materials in this project. So we looked at copper tailings, which showed high mechanical properties in our mix design, good buildability, and then copper tailings are generally abundant in industry. Also looked at recycled glass. Recycled glass gave us good workability. However, it gave us lower mechanical properties when we compared to sand in our material mix. We are still investigating the impact of construction waste and the impact of oil sludge. Now, in the experimental program and method, in the first phase, we focused on the availability of 3D concrete printers and the categories. In the second phase, we looked at the cost of these printers. The third, we looked at the materials approach. And in the fourth, we compared the labor cost. And finally, we looked at, we compared all the technologies in one slide. Now, to do a cost comparison, we had to pick a house. So we chose a typical RDP house, or something that looked like an RDP house, which had a 40 meter squared. Excuse me, this 40 meter squared house. It had a 1 bedroom, a bathroom, a living area, a kitchenette, a wall height of 2.4 meters, wall area of 92 square meters, and a wall volume of 12 cubic meters. So this is similar to a standard RDP house. Now, after our research, we came to these conclusions, and this is the overall summary of the results that I'll be presenting here today. With regards to materials, what we see is that the robotic arm system and the gantry-based system uses less material as compared to the brick and mortar. And the reason for this is that you have the flexibility with regards to the printing pattern. When you are using these technologies, and you manage to avoid wastage, which we've seen as a big advantage. And with regards to delivery time, between the brick and mortar and robotic arm system, there isn't much difference, but we've seen a lower delivery time with the gantry system. Now, with the material cost. For brick and mortar, we got 140 rands per square meter. And for the robotic arm system, we got 906, which is significantly big. And the reason for this is that with the robotic arm systems, there's normally proprietary material that's used, And when you look at the gantry system, when we did our research in the gantry system, we got 108 per square meters. And the reason why we're able to get 108 is because with the gantry system, we're able to use the mix similar to the one I referenced when I started my presentation. Now, with regards to the labor costs, the going rates are around 1,200 for brick and mortar per 1,000 bricks. And with regards to the robotic arm system, the manufacturer's prescription is that two skilled people are required to operate the machine and print the walling that we printed in this program. I mean, with those specifications I showed earlier. And with the gantry-based system, the manufacturer also recommended 2 or 3 people, and which cost around 18 rands per square meter. Now, with regards to the equipment and machinery cost, brick and mortar costs 79 per square meter, but as expected, it will be higher for 3D concrete printing machinery. The robotic arm system that we had cost 2.7 million, and our calculations gave us 80 rands per meter squared. So with the gantry-based system, the machine that we worked with here cost 3.6 million, and that gave us 60 rands per meter squared, which was expected as these machines or technology is quite expensive. Now, overall, the brick and mortar cost 238 per square meter, and robotic arm, mainly due to the expensive material, cost 1,000 rand per square meter, and the gantry system cost 186 rands per square meter, which is not too far off from the brick and mortar system. So in conclusion,
you are concluding, so that is fine.
yes,
Please proceed.
I think I have 9 minutes. I'm on 9 minutes now. So
maybe I documented it inaccurately. I thought you were over time. Please proceed.
Okay, so yes, many companies have taken on 3D printing, and it's a growing industry. And from the results we show, the cost of machines play a significant role to the output or the total cost at the end. And they assume that 3D concrete printing is really a viable option. And in my last slide, a viable and competitive approach could be to have the option to hire a 3D concrete printer machine for this technology to be feasible in the construction industry. And an investigation in 3D concrete printing pre-packaged mixed design could very be impactful. And the lifespan of these machines should also be investigated so as to durability, right? And the developing standards for 3D concrete printing will really be helpful. And what we've also observed is that a multidisciplinary approach is quite important to deploy this technology. Thank you, and thanks, Amir. I don't know if you can hear me.
I can't unmute myself, Trevor. Why can't I unmute myself? Trevor, can you hear me?
I can hear you, Prof. Your mic is on.
But it says muted. So, Refilwe, can you hear me?
Yes, I can hear you.
Oh, it's so weird because on my screen it says it's muted. But anyway, sorry for that. And you were right. You know, my notes are so messy. I need to work better on my notes. So I had the time wrong. You were exactly at 12 minutes, and I really appreciate that. Thank you for presenting your very interesting research. I'm just going to ask a final time if our presenters are here. Or not, then we will just move on to questions, comments, and concluding. I don't think they're here, but really interesting, Refilwe, and I think perhaps just to tie everyone's presentation. It would be great, Refilwe, maybe you could stop sharing your screen. And it would be great if all of us could switch on our cameras and we just conclude the conversation that way. So Suzette, Letitia, Polacano, maybe you can share your switch on your cameras, and Refilwe, maybe you can just stop sharing your screen, please. My system, something seems to be wrong with it, Trevor, because it's still saying that I need to unmute. So something weird is happening.
We can see you and hear you, for what it's worth.
It? Wonderful. Thank you so much. Polacano, are you still here?
Yes, I'm here.
Yes. Yes, so Refilwe, thank you so much. You're obviously studying something that is and researching something that's very important and could have wide applications.
Oh, signal is gone. But anyway, Refilwe, I wanted to know how long does it take maybe to build the RDP house using the robotic printer, 3D printer? How long will it take?
How long?
Yes.
Please clarify the question.
Like using building the RDP house using the 3D printer. How long will it take? Because maybe maybe it can take a month if it's brick and mortar the way we know it. But now with 3D printing, considering the fact things like drying up of the cement or the concrete walls.
Okay, Refilwe, could you respond to that?
For the walling structure, so my research was based on the walling structure, right? And we expect it to take an additional 2 to 3 days, maybe a day or two for the foundation and for the roofing structure. So all in all, you're looking at less than 5 days to put up a full structure.
Okay, so do you put, for the wall not to fall down as the printers, do you put some support structures on the sides? Because I just know 3D printing whereby we print with material like plastic or metal. That one, because it cures quickly. Now, I don't know about how concrete cures, because I think maybe fall to the side, or do you put some support structures on the sides?
Yes. No, a good question. We don't put any support structures, but we augment or we modify our recipe or the concrete. So we put what we call accelerators, so that as soon as it hardens as soon as possible, and yeah, we've realized that the material aspect is actually the most complicated aspect of the project, and not necessarily the machine. And yeah, but to summarize summarize my response with that, there's no support. We just focus on the concrete technology.
Oh, okay. No, thank you.
But then that also, in a way, perhaps responds to my question about applications in different contexts, because maybe this technology could be used for infill elements or components in multi-story, higher density city buildings, as an example. But also this idea of how to bring people into this. There's someone that I'm quite inspired by that talks about a building technology emerging from context and being rooted in context, and that is the only way. He actually says that's the only way a building technology will take root, that it will be adopted and used by people. And we had some interesting presentations this morning with regards to how there's a resistance in the adoption of alternative technologies. Yes, but at the same time, I am aware of what Akana said earlier about the need to develop products and innovative products. But then how do we do that in such a manner? And now I'm just saying this, maybe even Suzette from her experience. And Suzette, I think both of us are looking at the developments on site. The site that you're working at, and I'm looking at how building a fence now, and I'm loving the simplicity of the technology that you've adopted. Would you be able to, from your on-the-ground experience, make a comment on that?
There you go. Yes, I actually was hoping to get the opportunity to weigh in. Hi, Refilwe. I'm very excited by your work. I'm actually busy with a research project looking at alternative building materials now. And obviously a lot of the work that I do engages with housing delivery, state housing, and those kinds of things. I think my concern is mostly as somebody coming from the construction industry, that a building contract is almost 50% labor and 50% material. And the way that you're going to be constructing a building drastically reduces the cost that one would spend on labor. But how much of the country's economy relies on the provision of work through the construction industry? And what is the implication on the economy? Because I think in South Africa, we tend to favor technologies that increase the amount of people that are employed, because that employment stimulates the economy in the long run. So what exactly, like, do you have any thoughts about that? I'm not saying that you're sorry, somebody's making a lot of noise. I'm not sure who. But yeah, so I'm not sure how how you guys have taken that into account. And then my other thing is, so a lot of the work that we do looks at housing from an incremental point of view. So can a homeowner who is the recipient of an RDP house that was 3D printed, how easily can they start extending this house? Do they have to bring the concrete 3D printer in again in order to be able to do that? How adaptable is it really? And I think that speaks to Amira's comments about like technology emerging from context, and how like renovations and additions to small houses and backyard rooms and those kinds of things start happening because of context and need, and as people sort of develop their own aspirations, and how might you go about that? Thanks.
Thank you so much. Thank you so much, Suzette, for that comment. Yes, it's a complex issue, so I'm not sure if Refilwe, you're in a, if you do have comments on that, or anyone else. I think it's something that we're all grappling with. So it's great that Refilwe and his team are exploring that, and it needs to be explored. But I think we're all grappling with this issue of, as Suzette says, we need labor-intensive methods. We need methods where skills can be easily transferred. But I mean, I wouldn't mind if Polokano could actually also respond to that, in the sense that you're looking at product innovation. Are you actually looking at product innovation with that lens as well, in terms of labor intensive and social acceptability?
Yeah, actually, my lens is that we're looking for people to have the product innovation mindset, to be able to design products which people want, so that people can be able to buy those and push markets and have those people creating employment. Because currently people are buying products which are made in China, and it means jobs are being created in China as compared to here in locally. As regards the 3D printed houses, Well, we're looking for afford to machinery that can be affordable and be used to print our houses. So that if they have printed your house, then if those machineries are available and are cheap, and I can just call a company which has got that machine to come in and extend my house just by quickly 3D print the extension and then go.
Makes it. So, Letitia, do you have any comment to make?
Hello?
Yes. Letitia, sorry, there's someone called Claudio Mendes. Do you like to say something?
Yes, I would like to say something.
Please go
for Refilwe, I am an MPhil student at the University of Johannesburg. I would just like to ask, so like the advantages that the 3D printed houses have over like conventional, ways of building houses, is there like structural advantages to it, or is it just, that it's faster than conventional ways of building houses?
Thanks for the question. So from a structural point of view, there aren't many advantages. It's actually more complex, from a structural design, and it's generally not a structural design process that you'd want to undertake. But we're doing it, of course, for innovation and to see if this technology would really take off in the country. The real advantage rather is in the material avoiding material wastage. As I showed, that you've got a lot of flexibility with regards to how the building can take form, but still achieve the same properties as any other building. So the advantages really are more on cost saving from a materials point of view. And then the other question, I think it was from Suzette, if I'm not mistaken. I think it's a difficult one with the fourth industrial revolution and automation processes such as this one, because now if we think about what makes sense to make sure that more people are employed, or that more houses are built, right? So, because with the same budget, using 3D concrete printing, we can build almost 2 times the amount of houses that we would with conventional method. So, it's that dilemma also that we need to think about. And the other interesting one was with regard to whether it's adaptable. Unfortunately, there hasn't been much research, but the advantages that will be having our first pilot project next year with KZN University, the KZN provincial government, and we'll be printing a lot of social houses or social housing, and from there we'll be able to see, their durability and whether we can, extend them and so forth. So it's still really a gray area, but with the time we'll have a lot of these answers.
Do you know, to Letitia and then to Trevor?
Okay, so can everyone hear me again?
Yes.
Perfect. So I have more of a comment rather than a question, and it's maybe something that you can think about. So I looked at the projects, and firstly, thank you for the presentations. So Polokano and Refilwe, these projects, I look at them as becoming integrated, and I see it as somehow coming together. And I thought about this project in Helsinki, the capital of Finland. It's called the UDI Library. And what this library does, so it came out, it was opened, I think, in 2019, if I remember correctly, December. And what it does, it allows people to 3D print, laser cut, or develop anything that they want from this library. So it's a making space that's open to the public. And I think something like that links to architecture, as we often in architecture look at space and we say that space needs to become democratic. And I almost see it as something that we are struggling with in this social context and in terms of human responsibility and then also the technological advancements. I think of it as making technology democratic. So starting to think about the product design and the 3D printing. If you could have a space that's open to the public and where people are able to then produce their own product or even just start maybe making prototypes. And that becomes a way of making these new technologies democratic. And that is maybe a way where this then links to architecture and architecture provides spaces for that. So that's more of a comment, but I think maybe it could help you with future investigation and your research. Thanks.
And I'm seeing that innovation is already being taught at schools in Botswana. I mean, maybe there is a chance for, like you would have a public library in the neighborhood, you would have this maker space where you go and make things.
Yeah, those are some of the things we wish for. The unfortunate thing is that people say like resources. We wish we can have those 3D printers in schools. We wish. Thank you.
Thank you so much. Trevor, you had a question.
Yes, thank you very much, Prof. I'm not really in the architecture space, but I just wanted to understand from your review, and some of you are in the architecture space as well. I'm not sure if, because I didn't really catch that in your presentation on how you've considered how the employment of 3D printers in the construction can actually take away jobs, because I understand that it's cost saving, but then how many jobs are you taking away by just employing the 3D printer? I think, yeah, that's my question for you.
Yeah, thank you so much, Trevor. I think that was expressed in a way by Suzette. And yes, I don't know if Refilwe, you would like to respond to that again, but I think the concern that we're hearing now from the panel is we need labor-intensive technologies, and yours is certainly, you know, I have students currently looking at things like rammed earth and how rammed earth can bring many people into the process of actually making the building. I think it's an issue that we're all grappling with, and at the same time, you look at the housing backlog, Trevor, and you think that you need to roll out things very quickly and you need them in the millions. So I think, yes, it's a tricky thing, and I don't know if I want to wrap up now, but if Refilwe has a final comment to make, please do so. And Refilwe, you're working with Prof. Mahashi, and I really would like for us to have more conversations outside of this space. So maybe you could be our link, but if you have a final word to say on the issue of labor intensity, please do so.
Thanks, Amir. And yeah, Trevor, what we tend to forget is that if this thing, if we do get it right, if we do get the technology certified with the national building regulations, and there is a market, that there lies manufacturing opportunities as well, right? So then we'd have to manufacture as many 3D concrete printers as possible. So there might be opportunities from a manufacturing point of view as well, and that's something that is normally neglected. And what's also interesting, as I touched on a bit, is that the challenging part is the material design, right? And then there's a huge opportunity with material design development for anybody who wants to get into this space. So so there are or what's the right word? Opportunities around this, you know, and maybe we should start thinking around where we can create value and where we can create more jobs, but still pursue an efficient and cost-effective and a faster technology such as 3D printing. Thank you.
Thank you so much, Rifilwe. I saw, Trevor, was that really Prof. Mpufu with the hand up? Or?
Yes, it is Prof. Mpufu. I think he has his hand up.
Hi, Prof.
Hey, welcome, Prof. Mpufu. Yes, please.
Yes, I caught the discussion in the middle, but I thought we've got some work around this reconfigurable vibrating screen and brick molder. I know, I mean, maybe it's taking the discussion a bit backward, but I think with the challenges that we have with housing in the country, yes, we need 3D printers and all these wonderful technologies, but some of the basic technologies that are readily available within our institutions, we've designed them, we've prototyped them, we've patented them in line with the social impact that we want to see through this development of housing for the people. I think it's also important just to throw that spanner into the works that those people who have those powers to explore these technologies and consider them for the development of housing can also take some time and engage us and the team, and we see how we can work together to resolve housing issues. Thank you, Chair.
Wonderful. Thank you so much, Prof. Mpufu, for that comment. And indeed, I think we need to, like I said to Rifilwe now, we need to take this conversation further outside of this space, and we'll definitely engage with you as well, Prof. Mpufu. Yes, I think with that, that's really a good call for collaboration and further conversations from Prof. Mpufu, and I think it's a good way to end this session. I really appreciate it. As I said in my previous session, thank you to the established researchers that have joined us. Thank you to the new researchers. Thank you to the people we're busy making into academics and researchers. It is greatly appreciated, and I think we need these conversations between us, like, you know, someone like Suzette working on site, someone like Letitia interested in heritage issues, someone like Polokano interested in product innovations, and someone like Rifilwe actually working on product innovation, you know, so that we're not each like in our own space and not aware of everything else. I think we need these collaborations and we need these kind of spaces. And you've each added something of great value to this conversation. Thank you so much and have a good afternoon.
Thank you. Goodbye.
Okay. Thank you and goodbye.
Thanks.
Bye.
Bye-bye.
Good day. Good afternoon. How are you?
Very well, yourself.
I'm fine, I'm fine.
I noticed that you were actually
Pardon? I can't hear a thing.
Mr. Mfama.
Afternoon, sir.
Afternoon. I was thinking how I can see on the program that you were actually supposed to present in the previous session.
It says 4.
It says 4.
Yes, what I got, it says 4, between 4 and 6. And the email that I got, is it last night, it stated at 4 p.m.
Okay. That's fine. We're just waiting for the chair of the session.
Wow, okay.
Okay. Hello? Can someone hear me?
Yes, Mr. Sean.
Yes.
Yeah.
So I have another person that is working with me, John Karanja. He should be in the session as well. Oh, I see him. He's there. I got him. Okay. Okay. And I see John Theracon there. Yeah, we're good. Thank you.
Good afternoon.
Afternoon, sir.
Hello, Mr. Tarakan.
This is Professor Tharakan. I understand that my paper is in this session. Is that correct, or am I mistaken?
Yes, you're in the correct session.
Okay, great. I have my presentation uploaded on my screen. I'm ready when you are. When it's ready. Okay.
I'm just waiting for the chair of the section. I'm actually the technical person here. I'm not sure if the chair is joining us. I just want to quickly. Prof. Tarakan, you can go ahead and speak.
Oh, okay. I make the presentation, or?
Yes, I'm going to give you
the rights to be able to share the screen. So you should be able to share the screen.
Okay.
Right now. But I'm also informed that you share for this session.
I'm sorry?
I'm also informed that you are the chair for this session, Prof.
Oh, really? Okay. I did not know that. I was not aware that I was the chair of this session. I'm happy to serve as the chair. I'm happy to serve as the chair of the session. List of the papers, because I actually don't have those with me.
Okay.
Okay, from what I see on the schedule, there's paper number 68, paper 140, paper number 43, and paper number 116 are the authors of all those, and paper number 126. Are all the authors of those papers present?
(140) is present.
Okay.
116 is present.
140 and 116 are present. Okay. 40 and 116. Well, as chair of, let me go back to the program. 140. So paper 68, paper 140, and paper 116 are present. Given that we follow the order that has been listed in the program, do I have a chair for this session?
Yes, that is me.
Okay. Great. So, well, shall we get started then?
Yes, just to notify everyone to make sure that we are all on the same page. It's 12 minutes for each presentation.
Can you?
Yes, we can see it, Prof.
Is it?
Yes.
In the slideshow mode? Is it in the slideshow mode so you can see it in slide view?
Yes.
Okay, great. Well, good evening, everybody. Good morning from here, Washington, D.C., where I am in Howard University. I'm going to be speaking about technology transfer, human capital development, and capacity building, specifically focusing on the Shanghai Leadership Academy model. Just by way of introduction, I hold many hats. I'm first and foremost a professor of engineering at Howard University, where I have been for the last 30 years. I'm a visiting professor at SCMS College of Engineering in Kerala, India. I've served as a faculty advisor to Engineers Without Borders, and I have been a Fulbright scholar in India on 2 separate occasions. So what I wanted to speak about today really was what I see as many of the failures of tech transfer in terms of their impact on development, speak a little bit about transfer has not been supported and has resulted and sort of magnified the failures of development that we see, and then speak about the Shanghai Leadership Academy, which I feel is a model that we can use to actually educate communities to empower themselves to basically address the problems that they face. So I usually start off with this slide about where we can drink the tap water. And as you can see, it's maybe 10% of the population that can actually turn on the tap and drink the tap water. And what this speaks to really, because along with the fact that you can drink the tap water here, comes all the other support, infrastructure, services, and resources that enable a flourishing life. This is where you can't really drink the tap water. It's more than 70% or 80% of the world's population. And to address this, we need to come up with new development paradigms. And I think our keynote speaker today, Dr. Godfrey, Reverend Dr. Godfrey Zamujo, exemplified that. And what I wanted to was how his Leadership Academy really can be transformative in addressing this. So in that red space that I just showed over there, the state of life is quite difficult. We have over 1 billion people without access to potable water, more than twice that without access to sanitation. 3 billion people don't have ready access to the internet. All the things that make a flourishing life possible are not there, and have resulted in what we see around us. The question, of course, that I like to ask, oops, I'm sorry about that. The question is, how did we get here? Why is it that only 10% of the world's population can turn on a tap and drink the water? Well, these are the countries that Britain did not invade. So we've had history. We've had a history of 400 to 500 years of plunder, of resource extraction and transfer. And there was no, the technology transfer that took place supported the resource extraction. The British built the railways in India and Africa only to transport the raw materials that they were extracting to the port so that they could be shipped to the global north, basically, where the wealth could be created. So all that tech transfer is really not very helpful. And then we had decolonization and independence. And since then, we've had about 40 to 70 years, depending on which country you are focusing on and when we're talking about independence, whether independence in the 1940s, 1960s, or 1970s. All of those years of development have not resulted in real change. It's been a net wealth transfer from the global south to the north, and the net transfer of resources has as well been from the global south to the north, which is why we have such vast, huge, rich cities all over Europe and North America. But when we travel elsewhere, so what are the failures here? The tech transfer has been top down. There's been insufficient investment in human capital development. There's been no investment in community capacity building, and really very little operation and maintenance training. And these are the kinds of ways of top-down development intervention that have resulted in just failures. So we have, for instance, if you do the research, there have been over 1 million hand pumps that have been installed in the global south. More than 60% of those are not working right now. Why? Because they were not really supported. See that the development paradigm that has been followed for so long is actually quite appropriate. It marginalizes and devalues indigenous knowledge systems. It's really a development divide that results in undevelopment. So what do we need to do? We need to talk about what is the relevance of universities to confront the challenges facing Africa. And what Trina Zamujo has said is that every university should be a library of the African society that we want. We need, as he has said, to redesign African universities. We need to develop a knowledge culture. We need to be able to talk about adaptive knowledge enterprises, and we need to imbue the students of these Africana universities with a commitment to serve society. And we have to be focused on ways of generating new knowledge, but that generation of new knowledge has to be tightly integrated with social innovation, social entrepreneurship, and very much based within the community. What we see in the Songhai Leadership Academy is a much better model for technology transfer. It's a model that ensures human capital development, a model that facilitates and supports community capacity building, and basically it's focused on developing African human capacity, capital, both in terms of capacity and capability, as well as in terms of creating, producing, and disseminating the appropriate knowledge that will result in significant and substantial empowerment for the communities. What exactly do we mean by this approach? Basically, that provides an adequate framework and structure that enables communities to create the tools and the processes that allow them to use their natural resources, not simply to take those natural resources and get it taken out somewhere else where the wealth is created elsewhere. And this is so critical to the Songhai model, basically supporting communities to deal with all of the diverse development challenges that are there. So we can't really tweak, we can't just say, okay, we want to do this, we want to do that, and we can adjust things and things will be okay. We really need a paradigm shift that engages these phenomena. You have to take advantage of synergy. You have to take advantage of symbiosis within biological systems, complementarity. We have to collaborate. These are the underpinnings of what the Songhai Leadership Academy is and why it can be successful in forth. As Zamujo has said, we have to move from homo arrogans to biomimicry, focus on ecological literacy that does a paradigm shift in terms of our scientific and engineering thinking, where now we're focused on creating weapons of mass construction to build the society that we see. And I'm just showing you a few of the models of how things interact within the Songhai agroecological space. We have integrated that bring together primary production, small and medium enterprises, and support them with the technology and the marketing services that makes this flourishing possible. It integrates aquaculture, livestock, and crop production centered around bioenergy so that it can be sustainable. And if you look at the development model, it is highly located within the community and focused on basically developing the local community around. So that I will end my talk and open the floor for any questions. Stop sharing. I'm not sure if I went over the chair, but I don't have a timekeeper, so I'm hoping that I did not go over time here.
I'm keeping the time, Prof.
Okay, so do we have time for some questions?
Yes, we might have a minute or two. Well,
okay, I hate to be the chair of my own paper, but if there are questions, I'd be happy to engage in some discussion. I also put my email up, so if you want to engage in a longer interaction, I'm happy to do that on email.
Afternoon, Prof. When you started your presentation, you talked about that most of the countries that were not colonized by the Europeans, specifically the British, they had challenges in terms of infrastructure in relation to water transportation and sanitization. So what might be the cause that after so many years that those countries are free from the colonizers, they are still not getting it right? Thank you.
Well, I think one of the main reasons for that is because a lot of the development that occurs top down as opposed to being bottom up. So when you're bringing in people from the outside, you continue to make the same mistakes. I think the main thing here, and what Songhai model, I guess what is key to the Songhai model is that it is based in the community, and it draws on the resources of the community and is totally integrated with the community. So there's no question of an outsider coming in and telling somebody to do something. It's generated within. I think that's one of the reasons why the potential for success is much greater, and likelihood of failure is also much less.
Okay, thanks, Prof.
Do we have any more questions? Okay. Well, thank you very much for your attention. I think we can move to the next paper in session D1-3. Is paper number 140 present?
Yes, I'm present.
Hey, great. So could the host make you your screen sharing, sir? So just to continue, paper number 40 by Victor Malanga, Amos Adeni, and Lito Shabala, and Richard Mbaya. Very sorry for really massacring of those names. I sincerely apologize, but I look forward to the presentation titled "A Novel Method of Siloxane Removal."
Yes, can you all see my screen?
Yes.
Thank you.
Could you? Thank you. Okay, great.
Yeah. My name is Victor Mshanga. My topic for my presentation today is a novel method of siloxane removal from biogas processing using a fixed bed digester. I'm supervised by Professor Mbaya and co-supervised by Dr. Lerato Shabalala. This is my presentation overview, introduction, objectives, methodology, results, conclusions, and acknowledgement. South Africa is experiencing a high usage of energy. Can I just move this? Can I just move? Your screen is blocking some of my thing. Chair, your video is blocking. Chair.
Mr. Mhlanga, are you having some technical difficulty?
Yes, there is a screen for a chair that's blocking somewhere where I have to explain.
But I think on our side, we can see your presentation.
Or you can see my presentation, but I also have the chair thing blocking some of things that I can't read.
Okay. Prof, can you maybe, Prof. Tarakan?
I'm seeing Trevor Chihundla's things that is blocking my presentation from my side.
Okay, that is me. Let me see if I can fix that. What are you seeing on your side?
No, it's still there. Still there.
Maybe you can just tell me what you see.
There is a small box with your name in there that says Trevor, and it also show my video appearance at the bottom. Yeah, it is shifted below, but okay. Let me see that I can't. Okay, let me proceed with my presentation. I will see that probably I can navigate through it. As I've said, South Africa is experiencing a high usage of energy due to an increase of population and high industrial demand. However, due to the depletion of a conventional source of energy and the move towards green energy, new sources of energy have to be explored. The production of biogas from the municipality wastewater treatment plant is seen as an alternative source of energy. The biogas production contains various impurities such as siloxane, which act as inhibitors that can reduce the volume of the production of biogas and damages the Siloxanes are made out of silicon compound. They are physically and chemically inert. However, they are resistant to oxidation, high temperatures, have low surface tension, compressibility, and water repellent. During combustion of biogas, siloxanes are converted into a crystalline silica, which have similar chemical and physical properties. What happens usually is that the biogas it's used to generate energy, where you use generators that you convert your biogas into electricity. So during that process, the siloxanes, as they are highly volatile, as they evaporate, they tend to clog the equipment and make it difficult for the equipment to operate efficiently, and hence resulting into high maintenance and the downtime. Figure 1.1 shows the impact that the siloxane has on the turbines. As you can see from the left, the other side is clogged by the siloxane. Similar happen also with the boiler. The siloxane tends to clog your boiler, hence the lifespan of your equipment is reduced, and downtime and expenses comes with. The overall objective of this study was the utilization of an anaerobic treatment process for the reduction of siloxane compounds present in a municipality wastewater sludge in a fixed bed reactor. The specific objective of the study was as follows: to quantify and analyze siloxane degradation in a municipality wastewater using anaerobic treatment and optimization of a fixed bed digester. This is my research framework, where my feed comprises of the sludge from the wastewater treatment plant, cow dung, nutrients, and my digester, which is an aerobic digester, and the analysis that I carry out, that was the pH adjustment, the temperature, COD, and siloxanes. These are the materials that I use for my study: your commercial siloxane, your glucose, your HCl, your natural zeolite and activated sludge, and your cow dung. An aerobic 3.2, it's an aerobic digesting plant that I have in the lab that I've built. We have digester 1 and digester 2, which are our reactors, where our activated sludge is fed into. For both reactors, 2,000 mils of activated sludge was mixed with 200 mils of cow dung and 300 mils of water. And also nutrients were added to the feed solution to maintain the microorganism growth and the biogas production. 150 mils of glucose syrups, 20 mils of capric chloride, 20 mils of nickel nitrate, and 20 mils of magnesium nitrate were added as the supporting nutrients in the and the minerals in our digester. This helped to keep the microorganism within the digester active, and also reduce and also produce the biogas. Both reactor 1, digester 1 and digester 2 were immersed in a water bath under mesophilic conditions at a temperature between 37 degrees and 47 degrees Celsius. Those conditions are favorable in that temperature, favorable for the microorganisms that are responsible for the production of biogas to be active. Also, we had temperature control and our pH control within our plant. Method of analysis: a sample from the digester, a 5 mil of a sample from the digester is removed and taken into the centrifuge at 4,000 rounds per minute for 20 minutes. And then after that, that sample is filtered, and the filtered sample will remove 1 mil and dilute it with 50 mils of deionized water. And from there, we take 2.5 mil of a diluted solution and mix it with a digester solution and also with sulfuric acid, and put it in a thermodigester for 20 minutes at the temperature of 150 degrees Celsius. After that, the vials are removed from the digester and kept at the room temperature. When it's cool, then we take it through the UV spectrophotometer, where our COD is analyzed. See, the purpose of analyzing the COD is to be able to see that there is an activities that is happening inside the digester of microorganism. At higher CODs, we experience problem where there will be no production of biogas. The analysis of siloxanes, 10 mils of a sample is also extracted from both digesters, and the 10 mil of dichloromethane, it's 10 mils of diamethane is mixed with it at the separating funnels, where we shake the mixture until 2 layers are formed, and the bottom layer is extracted and then taken to the GC to analyze the presence of the siloxanes. This is a process environment condition. Since I mentioned that the biogas production is more sensitive to temperature so in this case, if you look at the figure 4.1, I've shown temperature range because of the experiment we have conducted during winter time here in South Africa. So the temperature in the morning and in the afternoon and later are not the same, and hence our water bath was not insulated, so it will vary from time to time. As you can see that from day 13, day 14, the temperature drops up below 33 degrees Celsius. This was due to the refill of our water bath, because the water bath was dropping below the heating element. The pH, as I've mentioned, in figure point 2, where we talk about pH acclimatization, where we have the controlled pH of the digester A and uncontrolled pH. We wanted to see that if we don't control the pH with hydrochloric acid or sodium hydrocarbonate, what will happen? Will the pH remain constant? And as it's shown that the uncontrolled pH fluctuated even below around 5.5. And with the controlled pH, we managed to maintain the pH between the range. The range that favors the methane production is from 7.3 to 8. We also compare the pH and the COD and see how the pH affect the CODs from the uncontrolled and the controlled one. As we can see that from A, that the controlled pH managed to maintain our COD below 10,000, and the uncontrolled one in B, we can see that our COD was fluctuating. Hence, this have serious effect in the production of biogas. If your pH, if we have a pH that is below 6.6, then the process of methanogens that produce methane cease to exist, and we have an acidogen process where acids take over the process because of the fatty acids developing there. So hence make it difficult for methane to be produced. Figure 4.4, the effect of COD on the accumulation of biogas. We can see from A that with the COD being controlled, we managed to produce around 4,000 mils of biogas, and with the one that uncontrolled, we managed to have about 1,200 mils of biogas. Figure 4.5 deals with the siloxane degradation using a zeolite bed in an anaerobic digesting process. So what happened is that the digesters are filled with the zeolite at a different bed height. As you can see, we have your 2 centimeter, 4 centimeter, 6 centimeter, and 8 centimeter bed height, trying to determine at which bed that we can have an optimal reduction of our siloxane. By the look on the graph, we can see that within 3 days, the 8 centimeter bed height, the siloxane was reduced from 0.448 to 0.4775, and with the one that has a smaller bed height of 2 centimeter, we can see that it took longer for the siloxane to degrade to that value. Hence, in conclusion, then the investigation of temperature and pH shows that the two parameters have an effect on the pH parameters, and have an effect on microorganisms in the digester and the production of biogas. The carbon dioxide is affected, the COD is affected by pH, and the COD have an effect on the production of biogas. The degradation of siloxane is influenced by the zeolite bed height. The greater the bed height, the effective is the degradation. I'd like to acknowledge the following people: that my professor Mbaya, Dr. Chabalala, Dr. Adien, Ms. Slotze, Swan University of Technology, and the Despot Water Treatment that allowed me to get the activated sludge from them. Thank you.
Thank you, Mr. Malanga. Thank you very much.
Yes.
Presentation. I think we have some time for questions, Mr. Trevor.
Yes, we might have 2 questions because it's actually gone a bit over time.
Okay, so is there any brief questions for Victor? I did have a question for you about, you said that this is a novel method of removing siloxanes. What was the prior method, and what were some of the problems with that prior method?
I think for the method that were used prior, which is expensive, they use the scrubbers. That is very, very, very expensive. So I try to see that by using zeolite as my bed, that will be able to remove most of the ammonium, which is the strong inhibitors in terms of gas production. So it will allow the microorganism to be able to degrade the siloxanes.
And in terms of scaling this, because obviously this has been done in a lab, on how you can scale this if you actually wanted to put it into a wastewater treatment plant.
Yes, up to now, I've been taken further from lab to the plant, because I've done this last year, and also with the challenges that some of the plant might have. I'm not sure whether they would be able to grant me that opportunity to use their equipment, but I will adventure into it and discuss with some of the people that I was working with at the Despot plant that wouldn't we try to apply this and see how it works. The other challenge is that most of the plant here in South Africa don't have the generators. They don't convert the biogas into electricity. There are a few plants, I think, in Joburg that has that. That will be, and they also have scrubbers there. I think that will be, it will be more advisable for me to try and work with them and see what can we get out of it. Thank you.
Thank you. Yeah. Are there any other questions for Victor?
Yes. Yes. I ask.
Yes, you ask.
Oh, I just want to know what is the root cause of this solar thing?
Beg your pardon?
What is the root cause
Of the siloxane?
Yes.
Yeah, the root cause of the siloxanes are the building materials, the cosmetics. Most of the cosmetics industry are the large contributors to these problems, and also the building materials. Those are the ones that are the contributors to the siloxane in our wastewater treatment plant.
Okay, very good. Thank you, Victor. I think with that, we will move on. Let us, Victor, if you could just stop your share, and we can now the next paper 43. But I understand.
I am present, sir.
Are you here?
No, my audio is fine. Yes, I'm here.
Oh, wonderful! Because I have been looking forward to this paper very much. So the next paper is 43, development of an automated coconut scraping machine, and will be presented by Braulio Mendes.
Braulio Mendes, yes, that's correct.
Okay, Braulio Mendes, please take the floor and show your screen.
Okay. Yes, is it up?
Yes, it is up.
Yes,
It is up.
it is. On slideshow. Thank you.
All right. May I begin?
Please do.
Right. My name is Braulio Mendes. I am a postgraduate student at the University of Johannesburg. I'll be presenting the development of an automated coconut scraping machine. I have as my supervisor Professor L.K. Tertibo and co-supervisor Mr. J.T. Kunene, both of lecturers at the University of Johannesburg. This presentation will outline an introduction, and then we'll have a look at the methodology, and then we'll look at the results, discussions, conclusion, and then some Q&A. For the introduction, we will cover research problem statement, research objectives, overview of coconut physical properties, manual and motorized coconut scrapers, and automated coconut scrapers. So for the research problem statement, the coconut grading is a laborious, time-consuming process with a number of safety hazards. This is because the operator is often required to hold the coconut against a rotating blade. Less laborious but more hazardous is the motorized version of the coconut machine. The scraping blade is sharp and may cause serious injuries in the case of an accident. Our research objectives is basically to produce an automated coconut scraping machine that is less laborious than existing technologies, a machine designed to be fail-safe and prevent the operator from reaching the rotating blades during operation. Simplicity in construction and functionality, easy to set up and operate. Let's just have a quick look at the overview of the coconut physical properties. So we can see that there is an outer coat and a middle coat. And then those two coats need to be removed, and the coconut needs to be split in half in order to be scraped. So roughly the coconut shell has a diameter of 100 millimeters, and the white kernel, which is the portion that we are interested in, is basically the eatable portion of the coconut. It's 11 millimeters. The shell thickness we have 3.5 millimeters, and the coconut shell has an ultimate tensile strength of 48.5, which is respectable, even can be compared to some engineering plastics. Having another look at some literature on manual coconut scrapers as well as motorized scrapers. On block A, we have the manual scraper. Basically, the operator simply holds the handle 52 and then scrapes by holding the coconut against the blades. For the motorized version, it's simply that the handle is replaced with a electric motor, and then it makes this process a lot more efficient. For an automated version of the coconut scraper, we have this Rubio Junior's design. It's what I like about this is the safety features of this machine. It creates the complete separation between the operator and the machine. Although the operator is required to hold the handle 54 and adjust the coconut against the coconut relative to the rotating blades. We'll move on to the methodology. The methodology used was research analysis, concept creation, detailed design, and then design analysis. So for the research analysis, we looked at the physical properties of the coconut to help in the design. We did a review of the coconut processing machines outside of scraping in order to bring the coconut to a state that can be scraped. We also reviewed coconut scraping machines to look at the different components or how it's usually set up, and then also the review of the safety features in those machines. For the concept creation, we created we used SolidWorks as our CAD software, and the requirements for the design was that the design was to be capable of movement in all three axes, in order to remove the need for the operator to adjust the coconut, and the design of a clamp to hold firmly the coconut, and as well as a control platform to automate the process, just simply to eliminate the use of an operator, and the machine can be fully autonomous. For the detailed design, we'll look further into manufacturing, acquirable manufacturing processes out there for our components, as well as off-the-shelf components that will be part of the design. We'll consider also standards, and we considered material selection, like for instance, the coconut is an eatable. So the materials in contact with this coconut needs to be, food grade materials, and operation and safety considerations as well. For the design analysis, once we have a detailed design, we'll run simulations, calculations using MathCAD Prime, as well as we'll review the results and input recommendations for optimizations. Looking at the results, we'll have a quick look at the development of the scissor mechanism, the development of the clamp mechanism, the development of the electrical power and control, and then we'll look at the general setup of the machine. Looking at the development of the scissor mechanism, we've managed to come up with a design that is capable of adjusting the blades to a maximum angle of 33 degrees. How does it do that? It does that by using an AC motor that transfers power via a pulley and belt system to the blades, so keeping the blades in a constant rotation, and also using a stepper motor to linearly push the linkage system, which I'll show later on in more details, the linkage system such that the angle can open and close while the blades are in rotation. Looking here into more details on the left, I don't know if you can see my mouse. Here on the left, we have the driven pulley assembly, which is not just a pulley, it's also a bearing housing holding a deep groove ball bearing for smooth rotation, and the lead screw and sleeve system is assembled to a radial type bushing, whereby the linkage system can then freely rotate around this bushing, creating a separation between the two systems, so as to maintain the blades in rotation, at the same time being able to adjust the range of the blades. Here we'll look at the development of the clamp mechanism. We managed also to achieve a clamp mechanism that at its unmounted states, it looks like that, but with the clamp arms are spring-loaded, as well as this end piece here is also spring-loaded. Once you push in the coconut in place, those arms, which are spring-loaded, tend to deflect, as well as the end piece also will deflect inwards. And following to the next step, once the coconut is far enough in, what happens is that the clamp arms, which are spring-loaded, will latch in place. And it was also incorporated the lead screw and sleeve system into this, such that the coconut can be pushed linearly in the direction seen in the illustration. In more details, I want to show the development of the same clamp mechanism. As you can see here, we have the compression spring on the end piece, and we have the torsion spring on the clamp arms. Once you push in the coconut, what happens is that the arms will deflect upwards, and once far in, it will latch in place, and therefore the operator can then tighten this rod at the back, and tighten the rod such that the spring can be at its solid length. This is estimated to take less than 50 seconds to mount the coconut in place. The development of the electrical and power control will be using an Arduino for the control as the control platform for all the programming. And then all those electrical components require a power supply, so we'll use a switch mode power supply. And then here is a conservative schematic of the control and power supply circuitry. Basically, the control circuit will control the three motors, one mentioned, two of the stepper motors and one of the AC motor. And then there is a current sensor that will sense the current changes due to the restriction on the rotating blade during scraping. So as the scraping takes place, there will be changes on the AC motor of the current range. So the current will increase or decrease in the range of the kernel, and those changes in current will be sensed by the current sensor and sent back into the Arduino, which here would be the control circuit, and then the Arduino therefore will know how to adjust both mechanisms to work with each other. So the general setup of the machine, here we have a middle compartment that shows, for instance, the image on the left, we have the lid open. This is the mounting position. The operator here can just mount the coconut and close the lid. And for the collection compartment, we have a sliding lid that allows the operator to remove the scraped coconut. On the left side, we have the clamp mechanism. On the right side, we have the scissor mechanism. Here is the AC motor compartment, and here we'll keep the control board and then also the power supply. Here is a see-through of the design. Basically, you can see here the clamp, you can see here the scraper mechanism. We use vents, and those vents, according to the calculations made, will dissipate around 10 joules per second of the heat created by the electrical components like the 3 motors due to their efficiency values. Here it's the process of scraping. Basically, on step 1, the clamp will move towards the rotating blade and will cut that portion. As the Arduino senses the current range changed, it will move the clamp back and then adjust the range or the angle of the blades again to reach that portion of the coconut until the process will continue until the coconut is fully scraped. Some specifications of the components that we're using is AC motor that with a power rating of 0.25 kilowatts, a stepper motor, which relatively less power consumption, and the Arduino, very little power consumption, and the power supply that pushes 0.115 kilowatts with those efficiencies. So basically the efficiency for the AC motor is 61%. The rest, the 39%, will basically be heat, be converted into heat, which needs to be adequately dissipated by the vents. The approximated machine weight will be 50 kilograms. The overall dimension will be 1007 millimeters by 497 millimeters by 403 millimeters. The machine input voltage will be in the normal 230 volts at 50 hertz. Looking at the discussions, so the research objective results to automate with the aid of an appropriate program, the scraping process can be automated. The scraping process is predicted to be rapid. The mounting time may be done in seconds. Fail-safe, the casing creates a separation between the operator and the scraping blade during operation. A limit switch creates an electrical separation during mounting and unmounting of the coconut. A straightforward operation of the machine was achieved. For simplicity, all of the off-the-shelf components are easily acquirable. Looking at the conclusion, for a summary of the final design, the design was created based on the project objectives and requirement. The literature review was, the literature was reviewed and analyzed. SolidWorks was utilized for all mechanical design, simulation, analysis, technical drawings, and general assemblies. The design achieved is capable of rapid mounting, autonomous scraping, rapid scraping, less hazardous than motorized and manual scrapers, and then easy to operate. The recommendations that I have is a detailed design of the electrical power and control system is recommended to be produced by a competent electrical engineer. Use of forced convection by incorporating fans to properly dissipate the heat. A prototype construction to allow experimental tests and optimizations. A redesign for mass production for both domestic and industrial use. Thank you.
Thank you, Braulio. That was a very interesting presentation. Are there any questions for Braulio and his coconut scraping machine? Braulio, I did have a question about how does your machine deal with coconut, with irregularities in the coconut shape?
Yes, the clamp mechanism that you saw, can I go back and show you the slide? So this clamping mechanism is estimated to be capable of accommodating basically any size of coconut or irregularities. Because with the we have three clamp arms and then a spring-loaded piece at the back to create sort of stability. So those arms basically can deflect or open to any size of coconut that is harvested.
Excellent. Other questions?
What is the throughput? How many coconuts?
I do have. Yeah, but go for it.
Yes, what's the throughput per minute or per hour or whatever the metric is?
Sorry?
What is the throughput? How many coconuts?
I think he was breaking off. Can you repeat the question, please?
Braulio, the question had to do with the rate at which your machine can process coconuts. How many coconuts per hour?
So unfortunately, a prototype was not built. This is simply design work. But I can estimate this. I can estimate it simply to be rapid, because I can have the AC motor on the scraping, on the scissor mechanism here. I can have this motor basically run at its full speed. So at this point, that's the only answer I can give you, as there is no prototype available for experimental, tests and all that.
I did have a question looking at your design and your technology. If you see where coconut is grown, many of these places don't have the sort of resources to maintain, complicated equipment.
Yes.
How do you? So one of the issues, one of the fundamentals of an appropriate technology is maintenance and maintainability by the community, and so on. So how could you address some of those issues?
Yes, this is okay. This is a theoretical sort of design at this point, but the concept is actually it's feasible, but this can be redesigned for any requirements, as in for domestic requirements or for industrial requirement. The concept actually is what I'm trying to convey, is that the concept allows for automation in coconut scraping, but this is not the actual design that it has to be. It can be modified for any for depending on the application, either domestic or industrial applications.
Understood. Thank you. Thank you. Are there other questions for Braulio Mendez? All right. Well, thank you very much, Mr.
Thank you. Thank you for the opportunity.
Next speaker, paper number 11, which has to do with block protocol incentivizing sustainable energy adoption, and the authors are Todd Shern and John Karanja, both of whom I believe are on the meeting. Go for it, or
yes,
John.
So Trevor, could you authorize John Karanja to share his screen, please?
Yes, I've done that. Hello, everybody.
Good evening.
All right. I'll go ahead and share my screen now. All right, so everybody can see that?
Yes, I can see it, John. It's good. Thank you.
All right. Then I'll let Professor Chan kick off.
Hello, everyone. I'm Todd Shern from the Howard University Computer Science Department, and our topic is blockchain protocol for sustainable and equitable token distribution in Africa. But it does have broader implications beyond distribution of solar energy. It could be applied to water or agriculture products or other commodities. In addition, it could be applied to wind power as well. John, next slide, please. So this project results from a senior project course to which one of my colleagues was the instructor. And we were approached by John and Bitcoin and other folks that were in the blockchain space about developing proof of work algorithms that could identify the next link in the blockchain. And so through this course, we actually had a student who developed a prototype using Python, which was actually implemented in Wive.io. But for the purposes of this discussion, we really don't want to go too far under the hood with blockchain protocol. And we really want to discuss more about how this Wive.io token could be deployed to appropriate type of communities where there is a need for local energy production. In the case that we'll discuss will be in Kenya, but it could be in other places as well. And what Wive.io provides is not only a mechanism for transactions surrounding the energy units consumed itself, but also it provides kind of a rewarding mechanism that incentivizes people to deploy solar energy and then make that solar energy available to others. So to discuss the specifics about the Wive.io deployment on a specific solar energy project in Kenya, John Karanja.
All right, thank you, Professor. So as Professor indicated, we are using blockchain technology, which is technology that is around 11 years old. And essentially what it does is it allows for the storage of transactions that could be happening on any network. And in our case, we're going to show it working on a solar crowd grid network to be stored in blocks, which are immutably secured by people who we call proof of work miners that that are rewarded using a token for securing these transactions. And these transactions are transactions of value that occur over a network. In this case, it's an internet-based network. So this is the solar use case we're talking about. It is a satellite picture of a village in Kajiado, Kenya. And it's a proposed crowd grid that we're designing and we want to implement to test this system. And as you can see from the image, we have a school, dispensary, and 2 homes. And we want to interconnect these entities, which all have solar panels, to be able to sell their excess solar capacity to each other. So for example, the school may need additional energy because obviously it's a big institution with many people needing access to energy, the students and the administration blocks, and they can get that energy from the dispensary or from their homes and vice versa. So these transactions that are occurring between these entities need to be recorded on a ledger, which we are now calling the blockchain. And the use case for our particular protocol is for trading solar energy. So we have a solution which is called the Melanin Smart Box, or in short MSBX, and that's how the prototype looks like. And it is a device that generates rewards and is allowing for peer-to-peer transactions for energy between producers and consumers. So as I mentioned before, within the solar grid ecosystem that we are developing, and each entity would need to install this box at their premises, and this box is connected to the solar panel system and checks how much power is being utilized and rewards whoever is utilizing solar power using the Wive crypto token that we mentioned. So this is a process flow that we have designed. And in this case, I took 2 households, and you can see each household connects directly to its own smart box that I showed in the previous slide, and they can transact with each other by buying the solar energy that they need. And for being members of this network, they get incentivized with the Wive token for using the solar energy. The interface in Africa would be airtime. So the household owner would go to the shop, buy airtime, load it into the system, and the system would then do all the transactions. So the system, as you can see here, is fully automated. So the Wive protocol has been under development for about 2 years, but these are the milestones for this year. And as you can see that we are currently on the last milestone, where we're developing a 3rd version of the protocol, which will allow for the use of a proof of stake consensus algorithm, which will make it more efficient, because we have to, on the ground, collect performance data between the entities that I described in the proposed crowd grid ecosystem to see how we can better optimize the protocol to ensure that it is sustainably rewarding the users on the network. So in terms of building capacity, as Professor Tharakan mentioned before, which is very important also in the African context, we are planning to train about 2,000 blockchain engineers through our academy across the African continent to be able to build, deploy, and maintain these solar crowd grid ecosystems, leveraging blockchain technology. So that is one of our key activities in terms of capacity building. So that's the end of our presentation, and you can get involved by visiting the website Melanin Academy to join the program, and Professor Shan's contact details are there as well as my own contact details. Thank you, and I'm happy to take any questions.
Thank you very much, John, and Todd as well. Thank you for your presentation and your engagement. I have to admit, in all honesty, blockchain and the ideas of blockchain go completely over my head, so I don't understand what blockchain is at all and how it actually has value. Chemical engineer, I don't have the sort of the smarts. Let me just say, I'm not smart enough to understand blockchain, but I do know that it brings a lot of value to transactions. So perhaps you could speak to how this will, directly address one of the things that Zamujo talks about, which is empowering a community. How does it empower people on the ground having this technology?
Yes, thank you. That's a good question. So if you look at this community that we have here drawn on the map, they do not have access to power at the moment. They are off-grid. So at the same time, the solar systems they would need to have to access energy are still pretty expensive. So you need a mechanism to incentivize them to adopt these systems because they're not aware of the benefits of solar systems. Currently, the current model used across Africa is to give them loans to buy these systems. And that's not a good approach because they get into what we call debt traps and they're not able to pay for these solar systems. So blockchain is useful because it flips the model on the head. It turns what is a liability, a loan, into an asset. Because what these entities here with value, and that value is determined on the market because blockchain tokens trade on open markets. So whenever they deploy these solar systems, they're able to get these tokens, which now become value, and they're also able to use the blockchain networks to transact energy, to buy and sell energy to each other. So blockchain is a game changer in that it creates a marketplace, an energy marketplace, using a very efficient economic model for people to access solar energy and get incentivized and also to trade with each other versus the current model where they have to get a loan and buy these systems and then struggle paying for the loan when they already have very little income. So that's
so
what
John. Hi, John. John, I have a question for you. You just mentioned the tokens. Do you all plan to develop your own cryptocurrency for this solar use case?
Yes, it is already developed, and the system has been running since February this year. So that is already developed.
What is the name of your cryptocurrency, and is it traded?
The name of the cryptocurrency is called WIVE token. WIVE.
Okay.
And it's not traded yet. We are in the process of doing a release on the market, a software release, when it will now be able to be traded on the market.
Will you keep track of, because one of the ways that communities grow and prosper is by circulating, if it's money, back into the community several times. So will you be keeping a track, or will you have some kind of software or what have you that keeps track of how I know you can track it through blockchain probably, but how it's circulating back and within the community? Do you understand what I mean? As far as the economic impact, it has to rotate back into the community several times before it goes into any place else. So,
yeah. I think that's a very good point. So we have a company, or rather what you'd call a startup, that's being built on top of this protocol. So the protocol just does the blockchain stuff. Then the company will have the user interfaces that collect the data on how the token is being used within the different ecosystems as it scales across the different markets. And then that data will now inform on what other applications should be built that enhance community participation. So that what you're asking is basically solved at a higher layer of, at a higher level, rather than at the blockchain level.
Okay, well, thank you.
Yeah. Thank you.
And hi, Todd. I don't know if you remember me. I live in Bowie, Maryland. I've talked to you several times before in the past.
Okay, so one thing I just wanted to add to what John had mentioned in terms of the value is that a lot of the value is accrued by the entities that install the solar panels. So when you look at the different houses and the churches, so whoever owned those homes and took the risk and went through the effort to install the solar panels, they're going to be incentivized to do that in two ways. One, they'll be able to sell their excess power or power they're not using. And two, they'll be quote unquote, they'll be able to mine for wives, which is kind of like mining. You hear people mining for Bitcoins. Well, that's kind of the same process where they'll be mining for WIVE IO tokens. So there's kind of a twofer deal if they install solar panels.
Awesome. Thank you.
Great. Thank you for that question, which was actually very important in terms of keeping value wealth within the community. I think one of the fundamental precepts of Zamujo's Songhai model is that wealth has to be created and retained within the community.
Yes.
You know, in exporting the cassava or the rubber or whatever, it's actually processed on site by the community, and the community has the know-how, the tech, and the knowledge capabilities to do that, and they're empowered. So that's what will tremendously increase the impact of retaining that wealth within the community. So thank you for that question. Are there any other questions for John? Okay. Well, thank you very much, John and Todd. I think we have a final paper in this session, paper number 126, an overview of sustainable adoption support framework. Are the authors not present for that paper? Okay, I guess they are not.
It doesn't look like they are present.
Doesn't look like they're present. So I guess we will, unless there are further questions or comments, we can, Trevor, can you close the session, or what's the protocol?
Yes, if there is no questions, I think we can close the session properly.
Okay, great. Well, thank you all for attending this and participating in this paper session, this parallel session, and we may now rejoin the main hall where, Trevor, do you know in terms of the program what the next panel sort of session is, where all of the members will be present? Or is this the last paper session of the day for?
I think it's the last paper session, John. I'm looking at the schedule now, and this is it. This is the last one.
Wonderful. Well, I know it's late, Pretoria. We're just trying to get some finish up with. Actually, we're just in the middle of the morning over here. I was having breakfast while I was moderating the session. So in any case, thank you all very much, and we look forward to continuing the conference tomorrow.
John, where are you located?
I'm located at Howard University in Washington, D.C.
Oh, okay. I'm just a few minutes from you in Bowie, Maryland.
Okay, great. Wonderful.
Awesome. All right. Thank you.
All right, everybody.